So in this part we'll start from where we left in the last part. So in the last part we saw about the various standard form and the canonical form of representing the various Boolean expressions. So let's start with the K-map in this part. So if we are able to properly get the canonical form from the any expression from the any given expression, if it is given in the standard form or the mean terms are also given, so we should be able to write it in the canonical form. So okay, so once the canonical form we have, the best, I mean the most comfortable way to represent the Boolean expression is by the help of this mean terms also. So if this canonical form is not given and if you have the mean terms or the max terms, then also it is easy. And in the most of the questions you will see that the mean terms and the max terms are given. Okay, either mean terms will be given or the max terms will be given. So then if the mean terms are given, we will combine ones. Okay, we will try to group ones, but but if the max terms are given, then we will group zeros. So either way we will be able to solve the problem. So let's start with K-map. So basically this K-map is like introduced by the person Morris Kornoff in 1953. Okay, so this is what about it. And this K-map is just the representation of the truth table itself. Okay, so it is nothing new, but the whatever truth table you have written, so it is the same truth table but written in a different form. Okay, so to get the K-map, first of all what we do is we decide the number of variables. So depending upon the number of variables in the expression, let's say the Boolean expression which you want to implement or which you want to simplify have two variables. So then the number of squares which will come in the K-map will be decided by this number of variables. So for two variables, the number of squares will be 2 to the power 2. Okay, so two variables, so 2 to the power 2. Everything in the digital, as you know, has to be raised to the power 2 because 2 is the base, okay, of the system. So 2 to the power 2. So 4 squares should come. Okay, then if suppose you have 3 variables, so 2 to the power 3 is equal to 8. So 8 cells will come in the K-map. Similarly, if 4 variables, so 2 to the power 4 is 16. So 16 squares should come in the K-map. 2 to the power means if there are n variables, then the number of squares which should come in the K-map should be 2 to the power n. So this is what the very first thing which you should know. So in the next slide we will see that how to draw the this K-map. Okay, empty K-map we will see, and then later on we will see how to fill the entries for various variables and so on. But the basic rule to solve this K-map is that is the identity, is the Boolean identity which we have seen earlier, which is a plus a bar is equal to 1. Okay, so the basis of all this K-map, the basis of why this K-map is able to solve this, simplify these expressions, it is because indirectly we are applying a plus a bar is equal to 1. So this is the identity, this identity is actually the base of your K-map, right? So what we will do is, let's say first try to see how a empty K-map will look for a 4 variable expression. Okay, so let's say if your number of variables are 4 and A is your MSB and D is your LSB. So A, B, C, D, there are 4 literals. So A being your MSB and D is your LSB. So then how to draw it? So what we do is either, you can consider this is what the structure of this K-map is, but my point is you can either consider the starting from the mean term here or you can consider it from here. Okay, I usually prefer it from here because this is what I have practiced since very long, so I am very much comfortable with this. But it is your choice. If you make it here, then I have to be little cautious, otherwise I may make mistakes. So this is your choice, the way you want to comfortable. And why I am like comfortable with this way, because in the most of the books I have seen that we started from here, so we take the MSB here. Okay, but this can be written here as well. So ABCD can also be AB here and CD here. So when you write something here, so what does it mean? That the variables which are going to show here is like the AB, the 2 variables, whereas in this column we will show this AB, whereas in this row we will show the CD. Okay, so this is this row. Now this particular, the numbering of this variables is not directly we represent it with this, but we use the gray code to represent them. Okay, so you see after 0 0 we have 0 1, then 0 1 1 for decimal binary, for decimal this is the binary for decimal, but for next should be 2, but we are not writing 2, we are writing we are writing this particular codes in the gray code. Why it is so? It is, we are doing this because we will, in the next step you will see that we will try to group some adjacent cells, and when we group these adjacent cells, what will happen? There will be some change in the literal. So that change is basically is useful to apply this identity. Okay, so a plus a bar is equal to 1. So wherever there is a change, that term will become 1. So the basic idea is this. So that is why to apply that particular identity a plus a bar is equal to 1, we write these things in gray code rather than the binary equivalent. Okay, so these terms are written in the this gray code. So be cautious about this. So first thing, very first thing. So this is what I want to show you. Now depending upon this, this is your MSB and this is your LSB. So A, B, then CD. So suppose you want to identify a particular cell. So I mean, first of all, let's see if this is a 2. There are 4 variables. So the number of squares, as I have told you, will be 16. So 2 to the power 4 is equal to 16. So 16 square equal squares if you want to represent. So you make a big square, then you divide it in 16 equal parts. So this is what is being done here. So 16 equal parts. Now what we do is we write the this for starting from the MSB, we write the terms, the literals here. Then for the other variables, the remaining 2 variables, we write it here. Okay, then we mark the cells. So to reach particular cell, we have to write the decimal equivalent of this 2. Okay, so A, B, C, D. So 0 0 0 0. So decimal equivalent of that is 0. Okay, so that is what is written here in the cell with the green color. Now for this cell you can see the code will be, gray code will be 0 0 0 1. So the decimal equivalent of that number will be 1. Okay, for this binary code 0 0 1 1, you can see that the gray code, the decimal equivalent will be 3. So it is coming in this order, 0 1, not 2, it is coming 3. So 0 1 3 2, or you can write it 0 1 2 3. Okay, then similarly for the other cells, if suppose you want to reach to this cell, then it will be 0 1 0 1. So 0 1 0 1, decimal equivalent if you find, it will be 5. Okay, so you see the address of this particular cell is given by this particular thing. Okay, so this group. So this is how you reach to a particular cell, and the presence of a certain mean term you identify, and then you fill up at the particular place depending upon the decimal equivalent of that mean term. Okay, so that is why we have seen that in the canonical form expression, that how to represent the mean term with certain literal, okay, certain something in the subscript. So that subscript is actually should match with this. So whatever subscript the mean term is present, we will fill it up here. Okay, so this was about it. So this was about mean terms. Similarly, when the max term will come, we will fill up the K-map with zeros. Okay, the presence of the K-map, the presence of the max term in the K-map with 0, whereas the presence of the mean term in the K-map is filled with 1. Okay, so let's say this is the first thing that we have to draw, the K-map, the empty K-map. So once we have drawn the empty K-map, then the next thing we have to do is fill up the entries. So there are 3 type of entries which comes into the K-map. So these 3 entries are the presence of the mean term is, let's say, suppose I am talking about the mean term. Later on we will talk about the max term also, but whatever I am talking about, the mean term is equally applicable for the max terms also, but the only difference is that the presence of the mean term is marked as 1 in the K-map, whereas the absence of the mean term is marked as 0. Okay, whereas in case of max terms, the presence of the max term is marked as 0, whereas the absence of the max term is marked as 1. Okay, the difference is this. That's what. If you know this difference, then you can fill up the entries easily, and then the rules, whatever we are going to discuss in the next slide, will be same. Okay, so we'll discuss the steps in this slide, and then the various rules which will require to solve this K-map. Now, I have talked about the two entries, but there is also the third entry. So you see, the third entry is called as don't care. So that don't care is like, you see, if suppose in certain situations where you don't know whether that term is present or not, or the term is an illegal term. The example being your BCD code. If suppose you want to convert a binary or decimal number to the BCD, so then we use the first 9 combinations, right? First 10 combinations from 0 to 9, and then the 6 remaining combinations are the illegal codes. This is what we have studied in our when we were discussing about the number systems. Okay, so in the codes we have seen that the 8421 code, the BCD code, have like 6 unused states or the invalid states. So those invalid states are marked as don't care. Okay, so this don't care is marked by cross. So you are not sure whether that term is present or not. Okay, or rather you can say that you do not worry about the presence or absence of that term, and therefore you mark it with cross. Okay, not with 0, not with 1. So in the K-map there will be only 3 possibilities which you have to mark. Okay, so only 3 possibilities which can come in the K-map. So one is presence of a mean term particularly, so that will be marked as 1. Absence will be marked as with 0. Then the third option is the invalid terms or the don't care terms. So those don't care terms are marked with cross or X. Okay, so this is what is. So once you have formed the correct empty K-map depending upon the number of variables, as I have told you earlier, then the second thing is, depending upon the expression, you mark the terms, the mean terms in the expression. Okay, so we'll see the examples both for mean terms as well as the max terms. So in case of mean terms, we will mark it the way I have told you. So once you have marked them, then the other thing is we have to group them. We need to group them, and the grouping is to apply that particular rule. Which rule? A plus A bar is equal to 1. So that identity, just to apply that identity, what we do is we form the groups. So that forming the groups is like a little tricky. So somewhere you may see that we should start with with minimum number of 1. So you will start with, let's say, 1 square, then you will start with 2 squares. Okay, so you will try to find, first of all you will see the adjacent cells. So the grouping is only allowed in the adjacent cells. If the cells are not adjacent to each other, then you cannot group them. The definition of adjacency is that the two cells should have only one change in the variable. If there are two changes, if two variables are changing simultaneously, then those two cells can't be called as adjacent cells. So two cells, wherever they are, okay, can be called as adjacent cells if there is only one variable change. One variable is changing. Okay, so if there is one change, then only you will call those two cells adjacent cells. So this please keep this in mind, because this is the most important thing. And the second important thing while forming the groups is that we should start from the biggest group. Okay, there is, like in some books you may find that start from this pairs and then form start from the pair and then form the quad and then form the octet and so on. But what I have as far as my practice, whatever I know is we should start from the biggest group. Okay, so we'll discuss that. But the thing is, whenever we are forming the group, so the first thing is we have to form the group as big as possible. So the main aim is to form the groups, and the first target is to cover as many number of ones as possible in a single group. So if you have tried that, if you've tried to form the biggest group of ones, and still if some ones are remaining, then try to form the other lower groups. Okay, in case of SOP. In case of POS, we'll group zeros. Then the next important thing is that these groups should be in the this groups should be in the power of 2's. So we will form the 2 to the power 0. So 2 to the power 0 is 1. So that is we can get a term for a single cell. Okay, so that is possible. So we can group a single cell. So single cell is grouping means it should not be grouped with anyone. So if single cell is remaining, then also that can be grouped because it is coming as 2 to the power 0. Now the next higher group will be 2 to the power 2. So 2 to the power 2 is 2 to the power 1. So 2 to the power 1 is 2. So then you can form a pair. 2 to the power 2 is 2 to the power 2 is equal to 4. So you can form a quad. Okay, but you see the point is 3 is not coming in between. So you have formed a group of 1 cell, then the group of 2 cells, then the group of 4 cells, not the group of 3 cells. So you never form a group in which this particular 2 to the power is not satisfying. Okay, so you cannot form a group of 3 cells. We have to form the groups of cells. The number of cells should be 2 to the power. Okay, so something like that. Okay, so once you have done this, then what we do, we combine all those terms. If we have like grouped the mean terms, then we combine them with an OR gate to get the expression. If we have grouped the zeros, then we combine them with AND gates. Okay, so depending upon which terms you are using, mean terms or max terms, we combine them and put the sign accordingly in between. Okay, so if it is sum of product terms, then the sum will come in between. If it is product of sums, then the product should come in between. So SOP and POS, okay, accordingly. Now once you have done this, then after getting this expression, what we do is we realize that expression with the help of our gates. So whichever gates are coming, basic gates, NAND gates, so the whatever is required, then accordingly we implement that expression. Okay, with the help of universal gates or with the help of basic gates. Okay, or if it is like some derived gates also, so that also we can do. So these are the basic steps to this K-map. Okay, how to solve this K-map. So these are the basic steps for the K-map. But the important thing is the grouping, and this being little tricky. So if you are able to form the this proper groups, then only you will get the correct answer. And this grouping is tricky, and I should also say that it depends upon the practice. So if you are the more you are comfortable with the rules, and if you have practiced, if you have sufficient practice, then you will apply the rules properly. But if you have not practiced well, then people make mistakes in applying the rules of this, this grouping rules. And in this K-map, this grouping is the most important thing. If you make mistake in grouping, then your answer won't be correct. Okay. The thing is, although the thing is that there can be multiple answers as well. It is not necessary that everyone who solves that particular K-map will get the same answer. There can be multiple answers as well. Okay, but because the way the groups have been formed can be different also, so that is also possible. So that is why I was telling you that it is little tricky as well sometimes. Okay, so sometimes if you match it with someone else, his answer may be also correct and yours answer may be also correct. Okay, so both of you are correct, but you are getting different answer. So that may be confusing sometimes. Okay, so don't need to confuse yourself. And if you have done the things, if you have obeyed the rules properly, then no need to get confused. So what are the rules of this grouping? So the very first thing which I have told you is the adjacency. So while forming the group, the first thing which we have to consider is the adjacent cells. As I have already told you, two cells will be called adjacents if there is one bit change. Okay, if there are two changes, if there are two simultaneous changes, then you cannot call the two cells adjacent. So to form a group of any number of cells, you have to check the adjacency. If two cells are adjacent, then only you can form the group. First thing. Then the related to it is the number of cells which you will use to form the group is 2 to the power n. So start with the biggest group first. So try to form the biggest group first. So the biggest group of 2 to the power n cells, let's say. Okay, then target the lower one, 2 to the power n minus 1 cells. Then target the lower one. At last you target 2 to the power 0. Okay, don't start from 2 to the power 0 to the power 1, but start from the highest one. So suppose you have a 4 variable K map, then try to group, let's say 2 to the power 4 is 16. So start from 2 to the power 4. So first possibility should be 2 to the power 4. So if all the entries, if all the squares are filled up with 1, then in the this particular K map, 4 variable K map, you can form this group of 16 cells. So that can be only the biggest group. So if all the cells are filled up with 1, so that a single group will come. Okay, so this single group of 16 cells will come. Okay, so form that, and the answer will be 1 in that case. Okay, so if all the entries are 1 in a K map, then your answer will obviously 1. So no need to solve it in that case. But if all the entries are not 1, then you check it for the lower number of 2 to the power cells. Okay, so 2 to the power, let's say if all the cells are not filled up with 1, if let's say one cell is not filled up with 1, so then you cannot group all the 15 cells, the remaining 15 cells. Now the next group which you can form is what? 2 to the power 3, so 8. Okay, so now 8. So now accordingly you will try to form the groups, whether someone is remaining, or then you have to check the various possibilities that what is the thing. So this is what the most important thing which we should target, okay, while applying the rule. Then the second thing is we should try to exhaust all the ones, all the adjacent cells, until and unless there is like all these cells are not all the adjacencies are not exhausted. Don't form a cell of single cell. Okay, don't form a group of single cell. Don't use a single cell. Use a single cell only if you have exhausted all the groups and you are not able to form any new group. Okay, at least a pair. You should try to form at least a pair. Okay, and if you are not even able to form the pair, then only use a single cell then only use the single cell as a group, and then corresponding to that single cell there will come a term in the answer as well. Okay, so the thing is that now when I am talking about the adjacency, it is most of the times it will be very easy for you to see the adjacency. Okay, because two cells here in the previous slide, if you see, if I'll show you the empty this K map again, so wherever you see the this 0 and 1, okay, so see there is like this AB remains the same, so no change, but the CD, so you see D is changing but C remains the same. So the three variables A, B and C remains same in these two cells, whereas D is changing, so these two cells are adjacent. Okay, whereas this four cells are also adjacent, because although C and D are changing, but AB remains the same for all the cells, right? So you see this, most of the times it will be very easy to check the adjacency, but at few times it will be difficult to check the adjacency, and that is what I have told you, that what you need to see is that there is only one single bit change. If this condition is satisfied, if there is a single bit change, then those two cells will be considered as the adjacent cells. And the important thing, why this is important is because you see, if you check this cell, the adjacency of this cell with this cell, okay, 0 with 8, or you check the adjacency of this row with this row, then you will find that these two rows are also adjacent to each other. Okay, why? You see, this there is this is 0 0, this is 1 0, so there is only one bit change here. Whereas if you see this, so for this cell and this cell, the things are same. So CD and C will be same for these two cells, so they are adjacent to each other. So that is why we say that sometimes it becomes tricky. So what we have to do is, we should, the rule is we should check for the simple rule is we should check for the adjacency. Okay, wherever it is, wherever we are getting the adjacency, we can combine those two cells. But for simplicity, you can consider that we assume that we can wrap these cells. Okay, so you can fold this particularly. So you can fold it like this vertically as well as the horizontally. So that is also possible. So after folding, whatever you get, so that will be the adjacent cells. Okay, so the folding is allowed there. So the leftmost row is adjacent to the rightmost row, and also the topmost row is adjacent to the leftmost row. Okay, so you should keep this in mind as well. And because of that, you will see when you will fold them, so all the four corner cells will also be adjacent to each other. Okay, so this being little tricky. So that is why I have told you that if you are doing it first time, K-map, then things looks little tricky to you. Okay, so if you apply the rules properly, then it is very easy. It's not difficult. Then once you have done, wrapped the cells, check the adjacency in all the possible ways, and if you have done it correctly, then the next thing is you check it for the cells. Okay, still if there is any one remaining, or the repetition of the groups is allowed if any ones are left in the cell. If some ones have not yet formed group, then you can repeat, some of the terms of one group can be repeated in the other group as well. But if you have exhausted all the groups, of all the ones, and all the groups are already formed, then no need to do the repetitions. Okay, then the terms should not be repeated to form the groups. Okay, and this is also a little tricky sometimes. Okay, then we have don't cares. So we first of all, this don't cares, the rule to use the don't care is that this don't cares should be used only if we are able to form the larger group by the use of this don't care. So the don't care can be treated as 1 or 0. Okay, it is our choice, but it can be treated as 1 only, it should be treated as 1 only if that the inclusion of that don't care is helpful in forming a new group. Okay, is able to form a larger group, then only you should use the don't care. If the inclusion of that don't care is not helping in form a new group, if is not helping in forming a larger group, then that don't care should be treated as 0. Okay, so don't care, that particular X mark can be treated as 1 or can be treated as 0 depending upon whether it is simplifying the expression or not. If it is simplifying, then we can use it as 1. If it is not simplifying, we have to use it as 0. Okay, so that is what the thing is, and this also people find little tricky. Okay, now once you have done this, then the corresponding once you have formed the groups, then what we have to do is we have to see the change. So whichever variable is changing, so you eliminate that variable, and the variables which are not changing, those unchanging variables will come in your answer term. Okay, so a single term will be a mean term in case of SOP expression, or when you have combined ones. So that mean term will have the variables which are not changing in that particular group. If a certain variable is changing, we will drop it, and we are dropping it because we have applied the identity a plus a bar, okay, is equal to 1. So that is why we are dropping it. And still, I have tried to explain it as much as possible, but if still you have any problem with this, then you can ask me in the doubt class as well. So these are the rules, and these are the rules to form the groups. And once you have formed the groups and obtain the term corresponding to that particular one group, then you have to just sum them up. Okay, if it is a SOP expression. So this is what the things about the grouping rules, and once you get the Boolean expression, then you implement it. So then we have already seen these steps in the last slide. So these are the steps which you have to implement here. Okay, to get the expression and the expression this implementation. So let's try to understand whatever we have learned so far for the K-map with some examples of certain variables. So I have not taken any example with 2 variables because it is very simple. Okay, but 3 variables, will start with 3 variables, up to 5 variables we will cover. Okay, and not for the 6 variables, because after 5 variables it becomes a little difficult. So we'll keep it up to 5 variables, and then later on we will see the tabulation method. Okay, in the next part. So this part we will see up to 5 variables, the K-map solution. So let's say this expression is given. So the question is, okay, we'll understand everything with the help of example, and you try to understand the things with me here. But if you are not able to solve it, then later on you solve the questions by your own. Try to solve the questions by your own, as many questions as possible from any of the book you want. Okay, whichever book you use, you try to solve it, and then wherever you find any problem, you just discuss with that to me. I have already told you the procedure, that what to do. You just give the questions to your class representative in the typed form. Okay, in the printed typed form. Then not the scanned copies. Okay, don't give me the images. It will be difficult for me to include those images in the presentation. So you give me the typed form, and then the typed form I will in the Word file. I'll show. I mean the common questions which will come. I will solve them for you in the this doubt class. Okay. So okay, you talk related to that with your class representative. So what we do here is like we try to understand the things with the help of examples. So let's say the expression is reduce the expression, this given expression, which have certain mean terms 0, 2, 3, 4, 5, 6, okay, using the K-map. Obviously you can simplify the same expression with the help of your Boolean identities, but I have already told you that what are the problems with Boolean identities, solving it with Boolean identities. So we'll not consider that here, we'll just consider the K-map. So let's try to solve this K-map with this expression, particular expression, with the help of K-map. And as you can see that I have already told you that it is the sum of the mean terms. Okay, so sum and n small. So this is showing you that it is a mean term. Okay, so mean term. Using K-map and implement it in AND or invert logic. Okay, so you have to implement it with the help of basic gates. That means, okay. So now let's say there are three variables, and you can see here in the expression that there are no don't cares. Okay, no don't care conditions are given. If don't care conditions would have been given, they would have been written here in the question. So in the next few questions, in the next particularly some questions, you may see it. So in this particular question, as there is no don't care, so no need to worry, no cross mark will come into the K-map. So the first thing which we have to see is how many number of variables are there. So in this particular see, as it is not written anywhere, okay, that how many variables are there, but you have been given this up to this 6, okay. So the highest number of the highest decimal number you can see here is 6. So you see 6 if you will see, and if you raise to the power something raised to the power 3, so this to include that 6, what you have to do, if you suppose you include 2 to the power 2, so 2 to the power 2 is 4, so 4 is less than 6, so 2 to the power means the K-map will not have 4 squares. The K-map will not be a K-map for 2 variables. The number of variables involved will be more than 2. Okay, if this would have been 9, okay, so 2 to the power 3 is 8. Okay, so then we have to include the K-map of 4 variables. So if nothing is specified here that how many variables are in the question, so then you check for the highest this whatever term is coming, and 2 to the power should be greater than this. So highest term whatever is coming should be greater than this. Okay, so 2 to the power n should be greater than this. So depending upon you choose the n number of variables, right? Okay, so then here you can see that the number of variables should be 3. So 3 variables we have chosen, right? So a, b, c, so 3 variables. So if 3 variables are there, then 2 to the power 3 is equal to 8. So 8 squares should come. So 8 squares we have arranged. Okay, so we have formed a, b, c. So as I have already told you, this is your MSB and C is your LSB. Okay, so 3 variables we have chosen. You might have chosen XYZ as well. Okay, because in this expression nothing is given, so I have chosen ABC. It is your choice. You may choose XYZ, PQR, whatever. It is your choice. So ABC is written. Now after writing this ABC, we know that the cell numbers. We know the cell numbers, the empty cell numbers. So see this. This is 0. So this is corresponding to 000. We have written here decimal equivalent of that 0. Okay. Then 001. So decimal equivalent 1 is written here. Then 011. So decimal equivalent of that is written here 3. Similarly 2, 4, 5, 7 and 6. Now once we get this, we have to fill up the entries. So you see 0 is present, so that is why this 1 is filled here, right? Then 2 is present, so we fill up 2 here, right? This 2 is filled up. Then this 3, so we have filled up 3 here. Then 4, so 4, where is the fourth cell is marked here? So you see this fourth cell is this one, so we fill up 1 here. Then 5, so this is also filled up with 1. Then 6, so 6 is also filled up with 1. Okay, now you see that nothing is filled in the cell number 1 and 7. It is because the cells are having value 0. So somewhere you may see that they are filled with 0, or if it is not filled up, I mean with anything, then it is assumed to be 0. Okay, so in this particular thing I am not showing it filled up with 0. So okay, this can be also the case. In somewhere you may find this as well. So you see, now once we have filled them up, then our next target is to form the groups. So how to form the groups? So we'll check the adjacency and we'll start with what? Biggest group. So you see, this is particularly biggest group and the adjacency. Two things we should keep into mind. So biggest group. So the biggest group of this 2 to the power 3 can be 8. So can I form the group of 8 cells? No. Why? Because 2 cells are having entries 0. So we cannot form a group of 8 cells. Okay. So we will not form a group of 8 cells then. Then we'll come to lower 2 to the power n. So first we have tried for 2 to the power 3. So 2 to the power 3 is 8. So that combination was not possible. Now next 2 to the power 2 we will check. So 2 to the power 2 is 4. So let's see, are there any 4 adjacent cells which we can group together? So this 4 cells are adjacent to each other, but we cannot group them because this is 0 here, right? Similarly, this 4 cells would have been, these 4 cells are also adjacent to each other, but we cannot group them because there is a 0 here. Okay, we can form groups only with ones, with the cells in which 1 is filled up. Okay, the cell in which 0 is there, we cannot use it to form a bigger group. Okay, so you see, we cannot form this group as well. Can we form this group? No, because there are 2 zeros, so we cannot form this group as well. Can we form this group? No, because there is a 0 here. Now, so if we have exhausted all these possibilities, then let's see, can we form, because you see here this 2 are 1s and then this 2 are 1s also. So, and if we try to fold this up, we know that these two are the adjacent cells. So this column is adjacent to this column. So we can form a quad with this 4 cells. So you see, and all the cells are filled with 1. So we will form a quad. So this pink here, this side and this side, you can assume this to be a single group. Okay, so this is a single group. Don't need to assume it. It is a single group. So you can assume it to be as folded. So this is wrapped and folded. So folded, so these cells are adjacent to each other, and you can check it the changing variables also. So for this 4 cells 0 and 1, variable A remains the same, whereas variable B, you can see B is 0 for this particular column, whereas it is becoming 1 for this column. C remains the same. C is 0 here in this column as well as it is 0 in this column as well. So you see, our B is changing, so we will drop B. Okay, and you see also A is also changing, so 0 and 1. So A is becoming 0 first for these 2 cells, although it is same, but if we consider all these 4 cells together, then A is also changing. So whichever variables are changing, we drop. So drop them out. So whatever is remaining, we include that. So you see, in this particular combination, the combination of this 4 cells, if we see, so the term corresponding to that will be what? It should be C. It should be something C. Okay, C or C bar, that we will discuss later on, but it will not have A and B terms. Okay, so A and B will not come in the answer term, in the term corresponding to this group, because they are changing. So for this corresponding, particularly for this group, your term will be what? See, it is C is remaining 0. Okay, so the answer term, the term in the answer will be C bar. Okay, so C bar. So you see, in the answer term, if you will see, so there is a pink term as well. So this pink term is corresponding to this pink group. So we have written a C there. Now let's see whether all the ones are exhausted. Okay, so you see that all the ones are not yet exhausted. There are still, after forming this biggest group of this biggest quad, that is the group of 4 ones. Okay, still you have some ones remaining. So is it possible to group them, this remaining ones, in a single group? No, it's not possible. If we see the rules, if we check the rules, then it is not possible. But is it possible to form a lower pair, that is 2 to the power 1? So we find that yes, it is possible to form the lower group, pair. Okay, so lower group, that is a group of 2 cells is called a pair. A group of 4 cells is called a quad. A group of 8 cells is called an octet. Okay, so in this 3 variable cell, in this 3 variable K-map, we have started with octet first. So we were not able to form octet. So then we thought about quad, and then once the quads have been formed, then we see for the pairs, not the opposite. Okay, don't start with pairs and then quads and then octet. This is wrong. This will be wrong. This will give you the wrong answer. Okay, so start with highest group and move on to the lower groups. So you see, corresponding to this particular group, if I say, so if we form this particular group, so this will be a pair, and still if you see, this A is same, okay, B is same, and C is changing. So for this particular group, C will not come, okay, C will be dropped. And what will be the the term corresponding to this orange cell or this orange group? So it will be A is your, A remains 0 for this orange group. So and A is A bar, okay, because it is 0. So A bar. And what about the B? So B is 1. So B variable is 1 in this cell. So the term will be A bar B. So you can see that this term is written here in the cell, okay, in the answer term. So A B bar, sorry, A bar B, okay. Now let's see the other term. So corresponding to this, we can form the other pair as well, because this one is still remaining. So if we form this pair, then your answer is AB bar, okay, following the same rule. So this is A and B is not changing. So B is also not changing. So this is B is B bar. C is changing, so we have dropped C here, okay. Now once we get this expression, now the things are very easy for us. Then what we do is we implement it with the help of our AND or NOT gates. So AND gates are used here, NOT gates are used here to get the this NOT or the complement of the function, and then OR gate is used to form this plus, okay, to OR them up, to OR the terms. So what we have done, let's say here we have variable A, B, C, okay, D is shown here, but it should not be, okay, so this is a mistake particularly. So it should have 3 lines only. So A, B, C are used here. And you take the A variable, because A bar from here, because you see A is here. So you take you make the complement of this A here and the A here directly. So wherever you require A, you take the input from this line. If you want A bar, you take the input from this particular line. Okay. So NOT gates are used to make the complement of the various variables, right? So for every variable you can see the complements are used. The complemented line and the non-complemented line both are available to us. Now once they are available, then you for this particular term A bar B, we use a AND gate. Okay, so we take the input from A bar and then the input from B. So then this becomes A bar B. Okay, then for this term we take the input from A and from the B bar term. So A B bar. Okay, then this from C bar. So C bar. So now once we get all these terms, now we have to put this plus in between. Okay, so plus, to put the plus mark in the hardware, we use a OR gate, and this is a 3 input OR gate. Okay, so this 3 input OR gate we have used. Now this here at the S you will get this expression. Okay, so this is where your expression is. Okay, and as we have used this mean terms, so that is why we have used plus here. So this is what the way you have to, this is what the method is, how you have to apply the rules in the K-map, how to fill up the entries in the K-map for any number of variables given in the expression. Then once you have filled up the entries, then form the groups. Once you have formed the groups, include them in the answer term, okay, accordingly as per the rules, and then you make the circuit for that, okay, a hardware circuit for that. In this case, we just require AND or invert logic, so we have shown that only. But if it is something else, so we'll do accordingly. Okay, so the video is getting a little longer, so I'll continue with the same thing in the next video. Okay, so thank you.